Question number 11 on the midterm. Prove the following identity. Show all steps. To prove an identity, you can either go from the left to the right. Let me get my pen. Wait a minute. Pen. Left to the right or the right to the left. Or you can go both directions and meet in the middle. Sometimes it's easier to do one or the other. In this one, because these are identities that break down into long formulas, we might suspect that there's something that's going to be canceled. So it might be easier to work from the left or from the right to the left. Also, I've already tried working from the left to the right and it didn't work. I could not get there. There was something I was missing. So I'm going to start with what's on the right, which I've already written here, and I'll expand it and see if I can turn it into what's on the left. I'm going this way. I'll put it in red so that you can see which way I'm going. I'm going this way because maybe that will be easier. So let's see what happens. Cotangent is cosine over sine. So this is going to be cosine x over sine x plus cosine y over sine y divided by 1 plus cosine x over sine x times cosine y over sine y. Now on top I will add those two fractions, and I will use the common denominator, which is sine x sine y. I have no idea if this is going in the right direction, but we'll find out. Hopefully we'll get somewhere. So to get sine x sine y, sine x, I'm using this one first. Sine x goes into sine x sine y. Let me get rid of that line. Sine y times, so sine y times cosine x. I'll put cosine x, it doesn't matter which order it's written in, cosine x sine y. Likewise, plus sine y, this one, goes into sine x sine x times, so sine x times cosine y. So plus sine x cosine y. Now, rule of whiteboard is always run out of space. Cosine y. So there's the top. On the bottom, these two are multiplied together. I have a common denominator of sine x sine y. So how do I turn 1 into something over sine x sine y? Well, it's just sine x sine y divided by sine x sine y. So there's my common denominator. And then this is plus cosine x cosine y. Oh, this is starting to look like something that we can work with. Now, here's the top fraction. Here's the bottom fraction. The numerators, if they're the same, can cancel out. The denominators can cancel out. So that stuff is gone. And that leaves us with, and now I'm going to take advantage of cut and paste. That's going to leave us with this in the numerator. I'll put that over here. I may have cut off a little bit, but no one's perfect. And then this is in the denominator. Well, that's in the denominator. Does that look familiar to you? What's on top? That's sine x plus y. If we put this one first, we can write them in any order. Sine x cosine y plus cosine x sine y divided by, and I'll put this one first. It doesn't matter because they're plus. Cosine x cosine y. You might be recognizing what's going on here. Sine x sine y. So the top is just sine x plus y. And the bottom is cosine x minus y. And that gets us from the left, which was cotangent x plus cotangent y over 1 plus cotangent x cotangent y, to the right, from the right, what was on the right originally, which is all that cotan x plus cotan y over 1 plus cotan x cotan y, to what was originally on the left, which is sine x plus y over cosine x plus y. We have proven that they are equal.